Hello, this is for Math 10 class for tomorrow's lesson, March 25th. So we're going to learn 4.3, okay? 4.3, we are going to learn logarithmic functions. What is a logarithmic functions? It's a function contains a log. It is called a base, okay? You can see the base cannot be 0, cannot be 1, have to be bigger than 0. The x here, the one you take logarithm to, has to be greater than 0 also. But for the y, okay, the y, it can be any number, okay, positive, negative. So for y, it will be negative infinity to positive infinity, so any number. Now to convert logarithm to exponential functions, how come? How come they have to convert them together? Because these two are actually inverse each other. We learn by inverse function, right? So when we're going to convert from logarithm to exponential function, all you do is change this base, a little base to a bigger one, and then switch these two positions. Okay, that's all you need to do. Let's look at problem number 12. Okay, number 12. Here given, I just do A. Okay, here given log 5 1 over 125 equal negative 3. Okay, and then now change this into base to a bigger base. Switch this one to here, switch one to other side. Okay, that's all you need to do. And let's try another one. And here is number 16. A. Ln x plus 1 equal to 2. So now, what's the Ln is? Ln is a base E logarithm. Means that here the base is a E. They didn't write it. When they see Ln, that means the base is E. So we go E, switch this to the other side, this go to the other side. Okay, that's how you switch it. And now we're going to learn how to switch back. Okay, how do you switch back? So now we're going to learn how to switch back. And here's one. It's problem number 20. Okay, number 20, we have part A. It's a to the, not A here, 4 to the negative 3 over 2 equal to 0.125. And now you can write logarithm on it, so we go log. This is 4, this is a base here, coming to a little bit now. Switch their position, okay, just not how the other one. Big base become a small base, switch. The other one is a small base become big base, and then switch, okay? So that's how you do this one. And let's look at number 24. It's a E, part A, E x plus 1 equal 0.5. Okay, well, E use Ln, so Ln, you don't need to write the E anymore, switch them, 0.5 equal to x plus 1. So Ln is a special logarithm. There's a lot of special one too. Okay, so now we learn how to switch back and forth. There are basically two special logarithms. Okay, two. So the first one's called a base E logarithm. They use Ln. This means log E. Okay. So once you see the E, you write like Ln. One is the base 10. Oh, one more thing I want to tell you. This one, there's a name for it. We call the natural logarithm. Natural log. And base 10, we have a LOG. LOG, it means base 10, it means like this. But we don't write a 10, okay? When we have base 10, we just write LOG. And this we call the common logarithm. And if you look at your calculator, you realize your calculator has this notation and that notation. So when you see this notation, that means the base is a 10. When you see this notation, that means the base is E. So now after that, we're going to learn a few properties. Okay, these all need to be memorized. The first one, if you take a base of 1, is always equal to 0. Now I use LOG, you can see LN also, okay? I just list one of them. Number 2, if you're going to have a base and this number is exactly the same number and this is equal to 1. Number 3, if you have base and this one is equal to have any power, okay, it's equal to A. So you can see base 1 here, okay, come down. So this is a power get to here, this one get to here. As long as they are same here, okay, as long as these two numbers are same, these two numbers are same. Number 4, what happens if they are not the same number? Let's say I have a M, A, like this. These two numbers not the same. Then you can only put the A in the front. Okay, you can put the 8 into the front here and become not B, N. Okay, so that is the number 4. And number 5, if you have a B, not B, A like that. A, look at this. This is a base for exponent, and this is a base for logarithm. If they're the same here, okay, then you also equal to A. So that's all for so far for the property. And there's one more property I like, number 6. Okay, we have a couple more later on, but not in today's lesson. Is if you have 2 logarithm, if you have 2 logarithm the same base and equal to each other, then x just equal to y. Okay, these ones are called the 1-to-1 property, and these ones are very useful when we evaluate the logarithm. Okay, now let's remember the property and let's start to do some problems. Let's look at problem number 30. We have for A, we have log 5 125. What that equal to? And you look at the property, you say, well, these are 125, it's not 1. Well, these two numbers are supposed to be same, and they're not the same. These two numbers are supposed to be same, and then again, they're not the same here. So you ask yourself, well, can I make this one to be 5 to the some power? And you notice that 5 to the 3rd power also equal 125. Okay, so now you have the same base now. Okay, you can see here, this is a 5 here, and there's a 5 here. So once they're same, then you just equal to power. So that's equal to 3. Okay, this is 3 here, just come down. So that's how you do part A. Let's look at part B. And log 49.7. These ones are harder to see, okay? It's harder to see what power is that. 49 to what power equals 7. So if that's the case, I like to use this property, number 7. So what I do is I'm going to set this as an x first because I couldn't see. This equal 49 to what power. It's not like these points are really easy to see. So I'm going to convert back to logarithm form, okay? Exponential form. So the little base become big base. Switch this to 2. Okay. Now I need more room here. Now I'm going to make these two numbers the same. I know 7 squared also equal 49. Okay. Now use the one-to-one property. Oh, there's another one-to-one. I forgot to write it out. Number 7. Or number 6 apart. Or I can go number 7. Number 7 is that if bx equal by, then x equal y. They say if they share the same base, they're going to share the same power. Okay, that's what they mean. So now you look at here. These two are share the same base. This is 1 here. Okay, you can cut the line, take them away. So you have 2x equal to 1, x equal 1/2. And then then you replace this by 1/2. Okay, so that's equal 1/2. So you can use this also called a one-to-one property. So 2 one-to-one property. And so that's how you do part B. Both one-to-one properties, very useful. Let's look at part C. We have a log 9 square root 3. Okay. Again, it's a 9a is easy to convert. These ones like C is very tough to convert. We have no clues what this 9 to what power equal that. So we're going to let x. Okay, when you don't see it, just let it equal x. Now you're going to make this to be a bigger number. Switch this to 2. Okay. Then you say, okay, this is same as 3 to the 1/2. Okay. You want to convert bigger number to the small number, not this one to that. Okay. Because it's easier to go big to small than small to big. So 9 is same as 3 squared. Once they have the same base, okay, once they are the same, you can cut the 9 off. Let's take it away. Okay. Then you have 2x equal 1/2. And then divide by 2, and then x equal 1/4. Okay, divide by 2, same and multiply reciprocal 2, so it's 1/4. So this is equal 1/4. So that's how you do ABC. Okay, number 30. And let's try the one. Let's try number 32. This time we have a first. We have e to the ln square root 3. And the answer what they equal to. Okay. Well, these ones just use the property number 4 or number 5, I think. Probably number 5. Okay. If you can see here that they didn't write the e here. There's actually e right here. Okay. Because these two is the same. So by the property, this just equals square root 3. Okay. So that was pretty straightforward. And then part B, we have a e ln 1/pi. Again, that's the same thing, so you can look at this just a e here. If these the two numbers same, it's just equal 1/pi. Another one, C, they have 10 log 13. Well, when they don't write anything here, that means it's 10. Okay, so Again, same base, so this just equals 13. So this is pretty straightforward, just use the property. Let's try another one. Let's try number 34. We just need to practice a lot, okay? 34, we have I just do A log 4 square root 2. Again, this one you couldn't tell what is it, right? They're not the same here, and we don't want to try to figure out what will make them to be same, how to make them to be same. Not to waste time, so I'm going to just equal to x here. Now that this little base become big base, switch these two positions. So this is x on this side, now the 4, and the square root 2 go to the other side. And then that's equal to 2 and 1/2. Make this a 4 to become 2 square. The x was x before, and then once they're same, you can take it away. And then we have 2x equal 1/2 and x equal 1/4. Okay, so that's almost like the problem we just did on number, the problem we just did on number 13. So that is it for number 34. And now let's look at number 36. Number 36. Just part A. They said you have log 3x. This is 3 here. Let me write it bigger. Equal to -2. They want to know what x equal to. So, what we're going to do is we're going to convert again. Okay, so easier just to convert. So we go 3. Okay, the big base, as little base become big base, and then switch the position equal to x. So x equals 3 to the -2. And that's same as 1 over 3 squared. That's equal 1 over 9. Okay? So the flip the number. Negative means you flip the number and then square it. So that's for part A. And then let's go for part B. We are log 5 125 equal to x. And we just same we're going to convert it. So 5x equal to 125. 125 same as the 5 to the 3rd power. Again, once they're same, then your x just equals 3. So this one's pretty straightforward. Let's try the one. Let's try number 38. We have a part A, ln x equal -1. To solve for x, just this is base of y, so y here, change the -1 here and change the x here. Okay, so x just equal to 1 over y. That's all we need to do. Then let's look at for part B. Part B, the ln 1 over y equal to x. Okay, well, let's see, this is a y here, that right? So y to the x equal to 1 over y. But 1 over y same as a y to the -1. So again, once they have a same y, and then x equal to -1. I mean, same base. Let's see number 14. Okay, we practice a little bit more until we feel comfortable with it. The logarithms are always a little bit tough to understand. Number 14. A. we have log 4 2 equal to x. Again, little 4 here become big 4 and x equal to 2. Okay, change the bigger number to the smaller number, so make it be 2 to the 2x equal to 2 to the first. Again, once they are same base, take it away. 2x equal to 1, x equal to 1/2. Okay, so that's how you do number 40. And next in number part B, they said that log 4x equal 2. So that means a 4 squared equal to x. Well, that was straightforward. X equal to 16. So that's all you need to do for this one. And let's practice a couple more. Let's look at number 42. Part A, log x 1000 equal to 3. So we're going to go x to a third equal 1000. Okay. Small base become big base, switch their number. Now this time, you take the cube root. X equal to root 1000. When you take the cube root, you don't need to put a plus minus here. Okay, only the square root you need to put plus minus. And that's just equal to 10. The cube root of 1000 is equal to 10. Let's try number part B. So we have a log x 25 equal to 2. Now this time is x squared equal to 25. Then your x equal to plus minus square root 25 equal plus minus 5. That right? But remember we said earlier this base here cannot be negative, has to be greater than 1, but not equal 1, not equal 0, has to be bigger than 0. So this number x cannot equal 0, cannot equal to 1, has to be bigger than 0. Okay, so therefore you cannot take the negative sign, so we take just the 5, so x equal to 5. So that's for part B. And the last part is number 44. Part A, log x 6 equal 1/2. Okay, so we do the same thing. We said, okay, x 1/2 equal to 6. Now you need to take away the 2 here. So what do? So this is same as, square root x equals 6. Okay, you can look at it like that. And then you just square on both sides. Then your x just equals 36. Okay. And if you don't want to do this step, you can just square right here. That's fine, because if you take the square here, and this is 2 and this goes away, so x also equals 36. So either way is okay. And the last, so that's basically for today's lesson, okay? So be sure to do your homework and don't wait it all the way to the end, because we still will have exam and I haven't decided when's the exam.